So hello everyone. In the last session we have seen the charging and discharging of the capacitor. Now I have told you that in your exams they are not going to ask you the direct standard circuit. You have to remember the formula, but generally they won't ask you the direct standard circuit. Generally what they will do, they will give you some random circuit and then they will ask you some different things. So what we are going to do today, we are going to know how to write a equation for any random circuit. Okay, so let us start. So basically, if we see the things, then we will understand. Let us take some general circuit. Any general circuit I am going to take. Okay, not a fixed circuit. Let some general circuit. Okay. How to write an equation? You can give the topic name as how to write the equation. I will make this thing very clear to you because a lot of the student has a confusion regarding this. Okay, so suppose some general circuit is given. Let's take some example like this. Suppose this voltage is V, and suppose this resistance is R. Okay, here this resistance is suppose again R. This resistance is R, and there we have a capacitor. Here, that is a thing is given. Now for this, I want to know what is the charge in capacitor, equation of Q of t. I want to know that. How will you write? What is the concept behind it? How will you write? Okay, how will you write the equation for this? Can you tell me the equation? See, one method is very simple. What is a standard method is what? Standard method, what you will do? You will find the current in this branch. Suppose I1. That current you will find and you will put it equal to dq by dt, and from there you will calculate the q expression. That is a simple step. We know this thing, but that is a very lengthy. Okay, that is a very lengthy thing. You will do the proper, like you will do this thing, that thing, and then you will calculate. That is very lengthy thing, if you will see. Okay, so what we are going to do, we are going to see one formula for that is valid for any circuit. It doesn't matter what type of circuit is given. Okay, for any general circuit you can apply this formula. What is the concept? Basically, for any circuit, remember it is for charging. For any charging of capacitor circuit, or it is better to make it more simple. Let's make it more simple. What happened? Yeah, for any type of, you won't find this expression anywhere in the YouTube or any book. Okay, for any circuit, generally they will tell you the method, but they will tell you two different expression. No need to remember. Just for any charging, or let's take about the charging, because I can tell you that method, but okay, just let's use this method only. For a charging of capacitor, if suppose the charging of capacitor is given, then what is the expression of Q of t? They will ask. Generally they will ask this, because once you know Q, you can calculate everything, that is current and everything. Okay, what is the expression you have to remember? You have to remember Q max. That is a general expression I am telling. 1 minus e to the power minus t by tau. Where what is Q max first? Q max, that is a charge. Just give me 1 minute. That is defined as charge of capacitor at t equal to infinity, means steady state, at a steady state, or you can say at a steady state. At a steady state, I want you to calculate the charge at infinity. That is a Q max. Clear? That is a Q max. Now what is tau? Tau is defined as simply R equivalent into C. What is R equivalent? How to calculate this? See, first replace battery by wire. Okay, replace the battery by a wire. Simple. You have to replace the battery by a wire. Then remove the capacitor and calculate R equivalent across that. Calculate R equivalent across that. Okay, this is the rule. It's valid for charging of, if there is a battery in the circuit and it is given, you can apply this. And for discharging, I'm just going to do only a small change for discharging. Okay, suppose they will ask you for discharging, means when there is no battery, what you have to do, simply remember the expression will be, everything will be same, only the thing is going to be changes. Q max, this one will be removed from here. Okay, and rest of the thing are same. What is tau, what is Q max, that is same. Okay, so that is a, you can say that is a formula for us. Okay, and that is a concept for us. If you know this concept, you can solve all the problems. You can solve all the problems, literally all the problems you can solve. So this problem is very easy. Okay, so for solving this problem, first, whether it is a charging case or discharging, it is a charging case. So what is the answer? Answer will be this only. We know that answer will be going to be something like Q max into 1 minus e to the power minus t by tau. Now my question is that I have to calculate my Q max and I have to calculate my tau. First, let us see how to calculate the tau. Okay, first let us understand step 1, how to calculate tau. How to calculate tau. Okay, that is a step 1. Let us understand this. Okay, how we will calculate the tau for that. So what is the method I told you for calculation of tau? If you have remember, what you have to do, you have to replace the battery by a wire. See, this is the circuit. What is the method I have told you? Replace the battery by a wire, then remove the capacitor. And calculate the R equivalent across that. Means what we will do in the circuit, first we will remove the battery by a wire, or you can say replace a battery by a wire. So this is my battery, I am replacing it by a wire. Clear? Then whatever the circuit is given, just draw it. Rest of the circuit is same. There is no change in rest part of the circuit. Let me draw it. Suppose this battery, this is the point where battery is there, I replace it with a wire. This is my resistance R. This is my resistance R. Then it's told this is my resistance R. And then what is told? Just remove the capacitor from that point where it is connected. Just remove the capacitor. And from here you have to calculate my R equivalent. Now from this point, you have to calculate R equivalent. So if you see from here, you will find that this resistance and this resistance will be in parallel. Correct or not? This resistance and this resistance will be in parallel, and these two resistance will be in series with this. Are you getting my point? Array, what are the methods of calculation of R equivalent that you know? Okay, whatever method you want, you can apply. If you apply, you will see that my R equivalent will be nothing, sir. It is R by 2 plus R, that is 3R by 2. You will get this thing. So I can say, sir, my tau will be equal to nothing but, sir, 3R C by 2. That is the tau we know. Clear? Now the first step is completed. Now our second step. So first step is completed. Now second step, step 2. So we know the tau. Now what is the next thing we want to know? Let us see here. If you try to see, tau we got, only the one thing is left, that is a q max. Now how to calculate q max, let us see. Q max is basically defined as what? Charge at the in steady state. What is the steady state? What we, how to draw the circuit at a steady state? If you remember my discussion in the initial sessions, I think session 2 or session lecture number 2 or lecture number 1, I have told you that what you have to do whenever there is a discussion on a steady state, what you have to do basically. Yeah, in a steady state, the capacitor is going to be replaced by a open circuit that we have seen. A capacitor is going to replace by a open circuit. So what you have to do in the steady state, if you will see in this figure, in this question, basically what is Q max? Q max is a charge. Now you have to calculate Q max. And how to calculate Q max? Q max means at a steady state. At a steady state. And what is a steady state? In a steady state, we replace a capacitor by a open circuit. In a steady state, we have know that the capacitor is going to be replaced by open circuit. OC means open circuit. Okay, so let's draw the circuit then. So basically, see, whatever the steps I am telling, just follow that step blindly. Okay, don't use your brain. This is R, correct? This will be R, and this is open circuit. Okay, now you have to calculate the potential. See, this is YB, the current will flow like this. You know current and electricity, okay? So current in this branch is 0, obviously. So what is the potential at this point? So this will be V by 2, that you can calculate. Let us take potential 0 here. This is V by 2, so this will be also V by 2, sir. This potential will be also, because the current is 0, so this will be V by 2, this is 0. So what is the potential we will get, sir, across the capacitor in a steady state? So the potential at a steady state will be V by 2. So my Q max will be how much, sir? My Q max will be simply C into V by 2. That is a Q max, because Q is equal to C into V. So C is the capacitor value, and what is voltage? That is V by 2. So my Q of T will be, finally, step 3, my Q of T will be what? C V by 2, 1 minus e to the power minus t by tau. Tau is how much? 3 RC by 2. That is 3 RC into 2. Clear? This is the answer for this. So this is my Q of. Now once you get the Q of T, I can ask you I of T also, but remember this I of T is a current in this branch. Okay, it is not this current, because it is a charge across the capacitor, so this will be the current in the capacitor branch. Okay, that should be clear. That is a common sense. So have you understand the thing? There is no need to go and write do the complete analysis and do this. No, just you use this simple concept. Okay, this simple concept you have to follow and you can calculate. Okay, there is no problem with this. Clear? So let us do some example. Generally in the exam they will ask you to calculate the Q max. So in this example you have to calculate Q max, okay, because that is the only difficult task for you. So let us do some example and tell me the Q max for that. Okay, so let's take one example. Okay, to in this circuit you have to calculate Q max. Okay, then Take another example. Okay, just do the calculation fast. Okay. So this is 6 ohm, 2 microfarad, 4 ohm, 4 ohm, 20 volt. Okay. Next example. Okay, first solve this, then I will tell. First solve this. Tell me what is the Qmax for this. I told you the method how to solve. Tell me the Qmax. First you have to clear that when the Qmax will be reached at the steady state. When we reach the steady state, then we will reach the Qmax. Okay. So apply that condition. When a steady state, the capacitor will be replaced by open circuit. Apply that condition and calculate the basically calculate what you have to calculate. Calculate the maximum charge. Okay. So just apply that and calculate what is the maximum charge. Because the conclusion is that then at a steady state, the branch where the capacitor is connected, there will be no current. So that's why we are making the capacitor replaced by it by open circuit. Okay, this is 2 microfarad. Okay, not 24 farad. Okay, this is 2 microfarad. 2 microfarad. Yeah. Now calculate fast. Done. Okay. So let us see the solution. What you have to do simply in this, replace this by open circuit. This is open circuit. So if this is open circuit, this branch doesn't matter. Clear? So what I can do, this doesn't matter. I can simply write it as 2 ohm, correct? This is 1 ohm, correct? This is 3 ohm. And this is connected with a 12 volt of battery. But I want to calculate the potential at these 2 points. That is a potential difference only. See, they all are in series 3 to 5, 1, 6. So what is the current will flow? 6 divided by 12, that is 2 ampere. 2 ampere, so what is the potential here? That is 12 minus 2, that is 10 volt is the potential at this point. Or what is the potential here? Potential, what is the potential here? Because see, potential drop will be 4. So what is the potential here? Sorry, this will be 14 volt. So what is, sorry, not 14. Sorry. This is a 6 volt. Okay. So this potential is 6 volt. So what is the potential drop from here to here? That is how much? 10 minus 6 is 4 volt. So potential drop is 4 volt. So what is Qmax? Qmax is simply how much? 4 volt into 2 microfarad. That is nothing but 8 microcoulomb. Simple. Any doubt? Now similarly here also what you have to do? Replace it with the open circuit. Once you replace it with the open circuit, what is the circuit will become? Simply it will become 6 ohm here, and we have a 6 ohm here, then we have a 4 ohm here, and similarly we have a 4 ohm here also, and this is open circuit here, and that is connected to a 20 volt of battery. So 6 6 12, 6 6 12, 4 4 8, 8 and 12 parallel. How much? 8 and 12 parallel. What is 8 and 12 parallel? Or no need to even do that also. If you can understand, this is 20. Here this voltage drop is 20, correct? This is total is 12. Total is 12. So how much current will flow? 20. See, this is 20. This will be 0, correct? I want to know the potential at this point or this point, whatever, all are same only. So what you have to do, the potential will be how much at this point? If you see, this is a series connection, so this will be obviously 10 volt. Are you getting my point? This will be 10 volt because series. Similarly, this is also 20, 0. So what is the potential at this point? That is also 10 volt. Are you getting the point? Are you able to understand my point? Why it is 10 volt, 10 volt? So what is a capacitor voltage here? 0 volt. So what is the C? Q max? Maximum charge will be 0. And you can see also, this is balanced Wheatstone bridge. So there will be no current. There will be no current means no charge. Simple. So Q max will be 0. Any doubt? Okay. See, I will give only those questions which I have taught. Basically, I have and I have taught everything, everything. Okay, you can pick. I challenge you. You can pick any material from any coaching institute, whichever you think. Okay, I don't want to take the name of those coaching institute, but you go and you take the like problem sheet, DPP, any test series of any coaching institute. Okay, whatever the big coaching institutes are there, no problem. You go and just pick up and just take it and try to solve it, and tell me, and you tell me any question which is coming out of the concept whatever I have covered here. Not a single concept they can make out of the topic which I have covered. Okay, so just try to do the things which I am telling you. You can solve each and every question of any exam, any competitive exam. It doesn't matter whether it is a JEE mains, advanced or NEET or nothing. No, it doesn't going to be matter. Just you have to follow me. That is the only thing. Clear? Okay, let's take one more example. Okay. So this is suppose 4 ohm, 2 ohm, 6 ohm. Suppose this is 4 ohm and suppose this is 2 ohm. Again 2 microfarad is connected here. I connected it to a potential of how much? Okay, I connected it to a potential of 20 volt. Again same question. Okay, so how will you solve? Try to solve it. I give you 2 minutes. Try to solve it. Completed? Okay. Okay, so simple. What you have to do? You have to replace this thing with the open circuit. If this is open circuit, this is 20. This will be 20. This will be 20. Correct? Any doubt? So this is like it's very simple now. This you replace. This is 20. It is similar to like this only. This is 0. This is 20. This is 0. You have to find the potential of this point only because this is 0. We know. What is the potential? See, this is 6 and 4 are connected in series. So what is the potential here? 6 into 20 divided by 10. Correct? That is 12 volt. Yes or no? So 12 into 2, that is 24. So Q max is how much? 24 micro coulomb. Even no need to use your pen also, you can solve it orally. Okay, clear? Yeah, so these are the type of things question they can frame. Okay, so if I ask you, can you write the equation of Q of t for this? Can you write? What is the Q of t equation for this? See, what is Q max? 24 microcoulomb, correct? Into 1 minus e to the power minus t by, what is tau? What you have to do? You have to replace the capacitor, remove the capacitor, replace it by a wire. So when you replace it by a wire, this is a wire, that is a resistor, that is a resistor, and there is a open circuit. Okay, so first you calculate the tau. I will write it directly. First you do and calculate and tell me what is the tau value you are getting. First you try to calculate and tell me basically what is the tau you will get for this circuit. For this circuit, what is the tau you will get? Calculate and tell me. Use your brain. Okay, because examiner can frame any question, it doesn't matter, it can frame any question. Okay, Completed. If you see, if I remove this wire by a short, basically this wire will replace by a, this is going to replace by a wire. So this is a short path, correct? So current will come, a charge will come, it will go into this path only, or you can say current will come, it will go into this path only. There will be no current in this, so can I remove this part? Are you able to see? You have covered current and electricity. If you are not able to understand, then you have to revise your concepts. That is a thing. So if you will calculate, if the people are able to understand, 6 and 4 will become parallel, and that is a series with 2 ohm. Okay, simply I am writing R equivalent. Okay, I hope you understand, because these things all has been covered in the class. 6 is parallel with 4 plus 2. So what is the parallel of 6 and 4? 6 4 24, 2.4, 2.4 plus 2, that is 4.4. So the 4.4 into C, sorry, that is 4.4 into C, that is this much. This will become 2.8 microseconds here. So this is a Q of T you will get for this if you want to write. See, this is such a big circuit, but we can write in just in a single line if you know the method, proper method, in proper structure manner, or there should be no confusion in method. Okay sir, we have what you have to, no, if you know very properly, then you can directly write this. Clear? Any doubt? I hope you are able to understand that for any given circuit, how to write the QT, how to calculate Qmax, how to calculate R equivalent, and how to write the equation for any circuit, for any type of circuit. I hope this thing is clear to you. If there is any doubt for you from your side, you can tell me. If you have any doubt, you can let me know. Give me a 1 minute. Clear? Any doubt? So we can proceed further. So till now what we have seen is the, basically we have seen the circuit, you can say we have seen the development of how the capacitor has been involved, and what is the circuit theory behind the capacitor. Basically what we have seen till now is the circuit theory behind the capacitor. What is the circuit theory is used. We haven't seen the, what is the capacitance, how the capacitance is going to be changed, that thing we haven't observed. Okay, so now in this section, our now next topic or next consideration will be that how the capacitance is going to be changed with the different parameters, and how we can control the capacitance. Now we are going to discuss the capacitance part. Okay, so let us start. See, the first thing is the force between the, basically this is the part where from where the dielectric is going to be start. From here we are going to talk about the dielectric only. So basically what we are going to, now going to build the concept of dielectric. So let us understand one thing. See, as you have seen there in parallel plate capacitor, the parallel plate capacitor, sir, suppose this is a parallel plate capacitor, sir, we have a parallel plate capacitor like this. Suppose it is like this. Okay, we have a two parallel plates. Okay, the charge on this plate we know as plus sigma, this is as minus sigma, or you plus q minus q, whatever you can take, and we know there is an electric field is there like this, plus to minus. What is the electric field, sir? The electric field we know that is sigma by 2 epsilon naught. Sorry, not sigma by 2, it is sigma by epsilon naught. So what is the thing is there? The thing is there due to the electric field. Remember, due to the electric field, electric field between the plates, the plates will they will try to attract each other, correct or not? Because they are positively charged, first of all, first thing. Second thing, they have an electric field, so one plate will try to attract the another plate, each other, correct? Yes or no? Because there is nothing inside this, we have a vacuum, remember, inside this we have a vacuum, there is nothing, that's why we are writing epsilon naught here. Okay, we have a vacuum, so it will try to attract each other. So basically what is happening, one plate is applying a force on the another plate. Okay, so we can say one plate applying a force on another plate. That is a what here it is happening on another plate, correct? That is a thing which is going to be happening here. So our topic is nothing but force between the parallel plate capacitor. So my question is that what is that force? See, force is what? Suppose on this surface, what is the charge? Charge is Q by A. What is the into electric field? So force on the positive plate, if suppose I want to calculate, so what is the force will be? That is charge Q into electric field, correct? What is Q? My question is what is Q? So the Q will be sigma by A, correct? Sorry, not sigma by A. Q will be, what is Q? That is sigma into A, correct? Q will be sigma into A, sir. What is electric field? It is sigma by epsilon naught or sigma by 2 epsilon naught. Now you have to tell whether it is sigma by epsilon naught or sigma by 2 epsilon naught. If you have understand the conductor, there I have given the proper explanation also. Then you can tell me the correct, whether it is sigma by epsilon naught or sigma by 2 epsilon. See, whenever we are calculating the force, then we are considering the electric field due to all the charge particles except the charge on which we are calculating the force. Okay, by which we are calculating the force. Means what I am trying to say, suppose there is a one charge, there is another charge. I want to calculate the force on that charge due to this charge. So what I will do, I will multiply the charge with the electric field that is due to that charge, not due to that charge. Are you getting my point? Means whenever we are putting the electric field, that electric field is the field due to all the charges except the charge on which we are calculating the force. Means I would not consider that simply like it's a very simple thing. Suppose you want to like calculate, suppose there is a one charge Q is there, okay, and there is another charge Q is there. I want to calculate the force on this charge. So I will not consider the electric field of this. I will not consider this electric field. I will consider the electric field due to this charge only. Then I will able to calculate the force. That is the thing. Okay, that is the thing. So from here also, I will not calculate the electric field. I will not write this electric field. Why? Because this is the electric field due to this plate also, due to this plate. So it is a net electric field due to both the plate. But I need the, if I want to calculate the force due to the positive plate, on the positive plate, force on plus sigma, then what I will do, I will write the charge which is present on the plus sigma into the electric field that is due to the minus sigma. Are you getting my point? So this is the electric field due to the minus sigma, and what is that value? That is sigma by 2 epsilon naught. Are you getting my point? This will become sigma square A by 2 epsilon naught. Or what is sigma? That is Q by A. So will you put the value that is q square a by 2 epsilon naught, that is the electrostatic force you will feel on each between the plate. This is force between the plate. Are you getting my point? This is a force which is present between the plate. So what will happen if you try to understand this plate is going to attract each other like this, attract each other like this. So D will become 0. So what is going to be happen? Then D will become 0, correct? If D will become, now if I write here, due to this F force, due to this force, plates attract each other, correct? So D will become, tends to become 0. So what is the capacitance then become? Then capacitance will become infinity. That is not possible. That is not possible. Capacitance cannot be infinity. You can't make a infinity capacitance. That is not possible. What is a infinity capacitance means? With the charge is infinity, then only we will get the infinity capacitance. So that is not possible. Okay, that is not possible. It is impossible. This is not possible, not impossible. Okay, because some people will say, "Arey sir, impossible means I am possible." So not possible. This thing is not possible. Clear? So that is why. What is the thing we are going to do to prevent that plates to stick together? What we used to do to prevent this thing, to prevent this problem, to prevent this, we use a dielectric material. We use a dielectric between the, so that is why we use a dielectric between the plate. That is why we use a dielectric between the plates. So have you understand the reason why we use a dielectric? Why there is a dielectric? Why there is a need of a dielectric? Why we went for the dielectric? See, it is very important that you have to understand why we are reading that chapter. What is the reason for doing that? Like, you can't read like anything, na? There should be a reason. You have to understand first, like, why we are reading this. Okay, then we will go for the other conclusion and other things. But first, you tell me whether you are able to understand that thing. Clear? Is it clear that why we need a dielectric? Clear? Okay, so let us, if this is clear, so let us proceed further. Just note it down. Okay, so let us proceed further. So first we have to understand what is dielectric. Basically, what is dielectric? First, it is a non-conductive in nature. It is a non-conductive. Not even say not non-conductive. This will be not that much correct, or better to write it as is semiconductive. Is semiconductive. What do you mean by semiconductive here? Let me tell you. Semiconductive means charge will induce. Charge will induce. But inside, if I calculate what is electric field inside, if I want to calculate inside, electric field will be also non-zero. Means there will be, it's not, there is very small value and very small value. Like this is the property of the, like this material. Dielectric materials had this property that they are semiconductive in nature. In nature. Mean, what is the meaning of this? Means charge will induce, but inside electric field is zero, that non-zero, that is very small value. Means what we have did, let us understand what we have did. Basically what we have did, we have taken a capacitor. Suppose this is our parallel plate capacitor we have. Okay, we have taken this capacitor and we have given the charge. Suppose the charge on this is plus sigma, charge on this is minus sigma, correct? And what we have did, basically we have filled it with a dielectric. We have filled it with a dielectric. We have filled it with a dielectric. Clear? We filled it with a dielectric. Clear? That is the thing we have did. We filled it with a dielectric material. This is a dielectric material. This is what? This is a dielectric material. Okay, this is a dielectric material they have kept. So what is going to be happen? See, on this surface we know that inside the surface we have a charge plus sigma is there. This surface we have a plus sigma, correct? This we know. Similarly, this surface we have a minus sigma. Okay, so on this surface, what is the charge will induce? So it will induce a charge. Some charge will induce on this surface. What is that charge? The charge which is going to be induced on this surface, it will induce a charge that is minus sigma will induce. Similarly, we have a plus sigma will be induced. So this is called as a minus sigma I, and this will be called as a plus sigma I. Okay, minus sigma I and plus sigma I will be induced, correct? Okay, basically inside what is going to be happen, let us try to understand. See, if you see, there is a one electric field is there. Okay, there is a one electric field is there. Just please note it down first till here. Completed? Okay, so if you see from here to here, there is a one electric field we have, that is sigma naught by epsilon naught. That is the external electric field, you can say external, because this is the external for this dielectric material. That electric field is there, which was previously also there. But now due to this induced charge particle, there will be another electric field will be here, that is sigma I by epsilon naught, correct? That is another electric field. So what is my E net? If I will write my E net, if you will see, you will say, sir, this is sigma naught by epsilon naught minus sigma I by epsilon naught, correct? Basically what we have observed, every dielectric material has a something called as a dielectric constant. Something called as a dielectric constant, that is given by K. That is given by K. So basically what is going to be happen, if suppose my external, due to this K, what I can say, if my external electric field is E naught, basically I am saying my E naught is external electric field, that is sigma naught by epsilon naught. So what is going to be happen, the inside electric field will become E naught by K, that is equal to sigma naught by epsilon naught minus sigma I by epsilon naught, correct? That is going to be happen. Clear? So if I write my this thing, it will become sigma naught by K into epsilon naught is equal to sigma naught by epsilon naught minus sigma I by epsilon naught. So epsilon naught will cancel out. If I want to calculate sigma I from here, I can say my sigma I will be equal to, sir, sigma naught into 1 minus 1 by. So if I ask, that is the expression you will get. So for a conductor, if I ask you for conductor, if I ask you what is my K? See, in conductor, the inside electric field is 0 or non-zero? It is 0. This will become 0 only when K is equal to what? Infinity. So for conductor, K is infinity. For air, what is K? Or you can say vacuum, whatever you can take. For vacuum, K value is how much? 1. For vacuum, K value is 1. So these are the thing. I hope you understand this step. What I did. Basically, this is a property of a dielectric constant. The net electric field will become whatever the external electric field divided by K. And K is called nothing but a dielectric constant of that material. So what is the, from here, what we have got? We got our sigma is equal to sigma naught into 1 minus 1 by K, where K is called as a dielectric constant. For a conductor, this value is how much? For a conductor, this value is infinity. For a air, the value is 1. Clear? Any doubt till here? No. Okay, if there is a no doubt and you have understand the concept of dielectric, what is basically the dielectric is going to do? The dielectric is going to basically decrease the electric field. Okay sir, no issue. The dielectric is going to decrease the electric field. So basically my net electric field will be this. Okay, we understand the concept, sir. So how it helps? One help I understand, okay, sir, due to this the plates are not going to attract each other. That is a one thing I have understand. Okay, so due to the using the dielectric, by using the dielectric, what we have got, the point is, by using a dielectric, okay, by using a dielectric, the first thing we have understand is that the plates will not attract each other. First thing, will not attract each other. Attract each other. Correct? That problem is solved. Second thing what we have got? Second thing we have got that my capacitance increased. How? Let us see. How? Let us see. So if you try to see, we have a parallel plate capacitor like this. We have a two plates are there, and we filled it with a dielectric. Sorry, like it's not a straight, but treat it only. Okay, so suppose if we fill the dielectric, sorry, so this is my dielectric. It have a dielectric constant K. This is plus sigma, this is minus sigma. Obviously sigma will be induced, okay, no issue. But now and suppose the potential across this will be V. Now I want to calculate the capacitance. Capacitance we know that is Q by V. Okay, Q is same, that is Q we know, that is the same thing. Q is equal to sigma into A. If you want, you can put sigma into A V. What is V? V is defined as electric field into distance. Suppose this distance is, this distance we know that is this distance is D, and the area of the plate is A. So what is potential? Potential is defined as electric field. What is now electric field become? E naught by K into D. What is E naught? E naught is sigma by epsilon naught into K into D. Correct? Just put this value here. So what you will get? You will get sigma into A divided by sigma by D divided by epsilon naught into K. So you can see my capacitance is going to become epsilon naught into A into D into K. So this is my capacitance. You can see that the capacitance is increased K times. I can say my capacitance is now C capacitance in air, or you can say vacuum, into K times. That is the thing. So that is what we have observed. The capacitance has been increased. This statement is true. This statement is true only. Okay. So capacitance is increased. How it has increased? This is a proof for it. You can see my capacitance value is become CAR into K. Means my capacitance is going to be increased. That is another advantage with using a dielectric. Whenever we use a dielectric, we are going to increase the capacitance. Clear? Any doubt till here? Anyone have a doubt? If I have a doubt, please let me ask. Sorry, let you ask. Okay, you ask it. If you have a doubt, please let me know. Any doubt is there? Clear? So okay, so in this section we have seen the first thing is how to write the equations for any type of circuits. Okay, general expression we have seen for writing the equations. Okay, we have understand the general concept for writing the equations. And second thing we have observed is the after that is force between the plate, and why there is a need of dielectric we have understand. And then we have understand the concept of dielectric, what basically the dielectric is going to do. And the last thing we have seen, after using the dielectric, there are basically the three advantages. I have told you the two next advantage I will told you later, but remember that these are the two major advantages which is going, for that reason only we are using the capacitance. Okay, you can see from here also, by increasing this capacitance everything is going to be increased. See, energy is stored, you can see the energy stored is also going to be increased. Energy stored will also increase. Yes or no? Will also increase. This is also one thing you can mention, but yeah, this is a, like you can say, the result of this. Okay, but this is one more point you can add. But yeah, what we have observed, that is the by adding a capacitance, sorry, by using a dielectric, the capacitance of a parallel plate capacitor has been increased K times, where K is what? Dielectric constant. Clear? Any doubt till here? So I hope you have enjoyed this session. So if you have enjoyed it, please like it, share it, subscribe it. Have a nice day. Thank you.